We've made a tremendous amount of progress today configuring the Renovate Data General emulator to behave a little bit better than it has been so far. So I thought I'd just highlight some of the changes that we've made that have proven fruitful. We've made some modifications to the renovate.ini file. Here, I'll just go through that slowly. And then I'll talk about some highlights. Window size and window color hopefully are very straightforward. Other than that, there haven't been significant changes here today that we've noticed makes a difference. We have noticed that the DKP debug equals true is producing some results, and I'll demonstrate that in a little bit. But we have that parameter enabled here. We haven't seen, we're not quite sure if DKP needs to be 64K words or not yet. So that's still an unknown. I'll leave that as active for the moment. We still don't have any huge confirmation on CPU Nova or memory size 64. Maybe it does, maybe it doesn't make any difference. We've completely given up on DZP. We just think it absolutely does not exist in this demo version of Renovate, which is fine. Hopefully we can find a way around it. Now, let's go over here to the renovate.vc. There's still some big question marks on the parameters for the DKP drive. Since the DZP doesn't exist and we can't set DZP to model 6060, we kind of need to. I think our only hope is to figure out what parameters we need to set this for to match the Zebra 6060 drive for that style for the DG Nova. We know that it's not the 4047 Diablo 31 disk. We know that's not the case. So I would imagine that these things need to be changed. We'll be playing with these in the days to come. So of the significant changes that we've made, we're mostly user friendliness, as well as some crucial things like does it accept the enter key once the program is running or not. And the biggest changes we found were actually this one. I'll turn word wrap off just for the moment, or on I should say. Where did I got lost here? Yes. So this was making the backspace not work and produced a house symbol or baseball diamond home plate symbol. I don't know what else you want to call it. If we let the TTI mode, TTI be in DG mode equals true. So we disabled that. And I'm not exactly sure why we changed these and if it made a huge difference or not, but we're working pretty well without these. We may do some investigation on that later. But this was the biggest one. This was making the cursor or the focus go to the upper left corner of the screen always when we executed the Minicom Utility. And so taking it off makes this thing work much better, much better. And so I'm playing with some parameters here as far as attaching, some raw data to DKP. Nothing really significant as of yet. We've left these in from Bruce's screen grab, where he executed those commands here. You'll see that at least the ones that don't error out. Whoops. At least the ones that don't error out are the ones we've left here. Set MTA right lock false, enable MTA, and attach MTA0, MTA0.9 TRK. And we're playing with the content of MTA0.9 TRK. And then we're kind of toggling back and forth to load minicom disk utility.bin. Whoops. I keep doing that. These are in reverse order the way I started them. Yeah, this is the one that I wanted. Sorry about that. And we found out that this header thing at the top, right here, where these numbers are, we think these are memory locations. Not exactly sure. We're still studying to figure out exactly what those are. But we found that it made some differences. Again, with the visual, I opened these in reverse order. I got to fix that. So if we load the memory in the VC file, load mem minicom disk utility.bin, then these numbers look different than they do here. So if we don't load it, we see the numbers at the top look like this. If we do load it, we see the numbers at the top look like this. And the major difference is this number, 077377, changes to 063077, which might mean that could be the amount of memory available. I don't know. And then at the end, well, no, it would be the opposite, because this is with the utility not loaded. So this number is smaller with the utility not loaded and larger with the utility loaded. And then at the end, with the utility loaded, in the memory, we see doc P3, CPU, as opposed to not. We just see halt there. So we haven't exactly figured out what those mean, but those are some important notes from our accomplishments today. And these we haven't done anything with, so we'll just leave them there to remind us not to try them, because this is the error. And I should point out again that all of the errors that we've gotten in the past and other comments I've actually put in here in the INI file as we go along. So, DKP device equals 23. This produces an error, and this is the error that it produces. So I've been actually putting the text in there so that we can see exactly what happens. That way we don't have to keep trying it and repeating the same thing to get the result over again. We can see that result here. So I'm trying to make this a cumulative, both of these files, somewhat of a cumulative learning with the comments. Okay, so let's have a look at where we are here. I don't think that I wanted to change anything in the INI file. Here in the VC file, we are not loading mem. I think I will change that to load mem. We'll start off like that, so we expect to see the beginning line be like this. Alright, we'll do a file save, and we will launch. And here we go. Looks very nice, looks like a better color. One of the biggest changes that this made was that the, what did I say? It was this and this made. It was functionality. This was the biggest one, so that the cursor doesn't go all the way up here anymore. That's very, very nice. So now, start 377. We figured out what this was from the help file. I'll show you that here in a minute. Whoops. We'll just do this. We have a text dump of this on our page here about the renovate this version, our evaluation of this. Start. Okay, so right here, start address. Start program execution after IO reset. Input output reset. But here's the parameter, address. And so I looked throughout the entire help file here, and I might as well show everyone where it is. Here on the page where we're going to be hosting this video, we'll host it on YouTube, but we'll reference it here. Is this page right here with all of this information. So we have text help group 2. Let me hit refresh on this because I know I've made some changes. There we go. Ah, yes. This one right here, we typed the question mark at the renovate.exe command in order to get this one. And that looked like this. So I can't actually do this one from the console the way I've launched it. This one I just did in front of you. We typed the question mark at the prompt. So here's our text dump of this. It looks much, much nicer. So you could look at that for reference and to check what we're talking about here. And then there's this one. And we've put both of these as text at the bottom of the page, just in case you want to search it on the page. So because it seems like this was really, really important information. I didn't want someone to have to click on one of these to go off the page to see this. I wanted to be able to search for it right here on the page. I thought that would be extremely helpful. All right, so let's see what's next. I am going to reset this. We'll just kill it here and then restart. Alrighty. So we have loaded the program. So let's just start it right here. And we'll just do the start 377, which evidently is at memory address 377. And here it is. Looks much nicer, a lot closer to the Bruce's screen grabs because it's a blue screen. But now, instead of having the blinking cursor up here, it's so nice to have it here. And also the enter key is actually working properly, which made another huge difference. I know what it was. I'm going to go back to this file. These one or both of these was disabling the enter key from working after the utility was started. Okay, so now we have that documented there. Very good. All right, back here, we're dealing with, as far as we know, we're just recreating what Bruce did in his example, 40 megabyte drive. So we'll hit 1 and enter, and it actually works. Look at this! Isn't this great? So now we see the next menu, and I believe we're going to want to go disk to tape or tape to disk. Well, let's just try disk to tape first. And now we're seeing a menu that I haven't seen before. I think CPRO accomplished this before, but we've neatened it up a bit. So now we get to select a logical unit. Well, let's just start with logical unit 0. And besides, I think that's really all we've attached so far is logical unit 0, if I'm not mistaken. I don't think we've attached anything. Look at this. We haven't attached anything. So I'm actually going to attach something next time. This time we're not going to do anything. I made this change, but it won't take effect till I restart this. So I'll just hit 0 and select the tape file number. CR equals current position. I'm finding that CR doesn't work. See, it beeps at me, and it does not like that. Okay, so we'll try 0. Look at this. Ah, and I've also confirmed. Look at all this stuff. It's doing all kinds of crazy stuff. I have no idea what. This could just go on for a long, long time. I think I'll end this and start over again. Now remember, here I've attached this. Something I should have done, but didn't do. I'll turn that off so nothing is attached. Something I should have done but didn't do right at the beginning is do a show all devices. So the -D again is the disabled devices. CPU is disabled. Not sure what that means yet. But notice that we've successfully reassigned DKP from its default of 033, octal 033 to 027, and MTA is on its default 022. But this says what's mounted, I think. Unit 0 is mounted to this file, and this one is mounted to nothing. So let's just try that again. See what we get there. And we did determine that we need to have a caps lock on inside the utility to get it to work, because the lowercase letters I don't think are working very well or at all. Let's try. See, it doesn't like that. It starts over again. Okay. So we'll go disk to tape. All right, now it likes that. And we'll go with 0. And 0 again, since it doesn't like CR. Well, that's doing something. We think this is... It's all the same instruction. So I have confirmed that the DKP instruction here, what we're seeing, is a result of the debugging that we've turned on. So over here in the INI file, we have debugging turned on. Ah, yes, right here. I have some comments about that. DKP debug equals true. So if I comment this out, then that does not happen. It may just hang. Not quite sure. Well, why not? We'll just demonstrate that. Start that over again. Show all. Just so we all see what's what. And we'll start 377. Disk to tape. Select 0 and 0. Hey, hey! I guess it was doing a whole lot of stuff. Now, in disk to tape, if disk is nothing, it could like sit here for infinity. So maybe that's what was happening, where we saw this, but then the debugger was on, so it pushed this way up. So I can see there being value to toggling that on or off. But I suppose this is the point at which that was happening. And I haven't exactly figured out how to initiate the break command to tell this thing to halt yet. But we'll get there. All right, very good. So, I type anything, doesn't really do anything. Control break. Hey, control break! I just found it. That's fantastic. All right, now I know. Control break. Let me document that. All right, so now it looks like we might have some useful information here. I still don't know what all these parameters are, but we did get some fantastic information from somebody by the name of David, who contacted us over the weekend. Hopefully we'll be able to publish what he shared with us soon, where he actually disassembled some of the files that he downloaded, some of the tape extract files that he downloaded from our site. And we saw things that looked a lot like this. What I'd really love now is maybe to get a verbose log output of these things right here, the assembler language looking things. And the stuff that he provided us looks like this right here. This is actually an LU0 tape backup that he has disassembled somehow. So now we're hunting for things that look like this. See, when I see a JMP.+12.2, now I'm seeing something similar to that right here, JMP .-2. That's comparative to this. That's .+12. So, I guess the memory location is jumping in position of various locations. I don't know assembler language at all, but I have a feeling I'm going to be learning it, particularly for this language, as we learn how to get this machine to run on various emulators. So, what's next? Well, now that I know that this works, why don't I end this, and we'll try some different parameters here. Maybe we'll load something. What I want to do is maybe get back to whatever I did to create this. Let me see if I could pull up my screenshot of that so I can recreate it. Ah, yes, I think I remember now. So nothing here is attached. So we saw what happened when nothing is attached. I think the next test we did with attaching dkp0.raw, which should be, let me save this really quick, which should be a null file. dkp0.raw is a null file. So let's see what happens when that is a null file. So we'll start this over again. Okay, very good. And I'll turn caps lock on. Okay, 0 and 0. All right, this time, that's right. This is what I was expecting. Now, what I didn't do was I didn't toggle debug back on. So I'm going to toggle debug back on in the INI file, and I'm going to hit Control Break because I know how to do that now, and quit. And now I'll start that whole process over again. Isn't this cool? I think it's cool. It's wonderful to make progress after not knowing what you're doing for so long. 0. We still don't know what we're doing, but we're doing more of it. Ah, there we go. That's what I wanted to recreate. So here we have a log. Now, we reached an error in block 0. I suppose that makes sense, because, like, it's a null file. Like, the disk is completely empty. So I'm surprised we got all this stuff before we got an error. But let's have a look at what is here. So we got this scale here, this status scale, which according to, oh gosh, my page here. There we go. No, not that. There, that's what I wanted to click on. So here, let's look at what Bruce came up with here on this screenshot. All right, so he actually, I think he put in some false data, but data that is at least configured correctly, which we don't know how to do yet, but we're going to experiment and figure it out. So we see here that this is an exclamation point, an exclamation point, and it looks like these exclamation points are the status indicator on the scale. So the scale is just text that's painted out there on the screen, and then it adds an exclamation point for every increment that it goes up the scale, and that's what we would expect to see there. So I think that's what we were going to see here, but instead of that, we've turned that DKP debug on, and so we see all of the DKP instructions. And I wanted to point out that we see multiple addresses here. And again, this reminds me of the debug code, which is not this, but this we have over here. Oh, I'm just clicking all kinds of things, aren't I? There we go. The debug code that we have over here. That a very kind gentleman, but he used to be an Irish programmer by the name of David, sent us over the weekend. And again, I hope that we can publish this soon, because I think this will be very, very good. But this is the disassembled assembler, for lack of a better term. And so soon we'll be figuring out what all this stuff means so that we can understand it and really get our heads around how this system works, not only on the front end user interface, but also on the back end. How all of these bytes that we've extracted from tapes actually turn into this assembler language instruction and make this machine do stuff. That would be cool. But anyway, we see that here we got the same error that we did when we had disk logging off, or DKP debug off. We have a disk block error 0000, and there we go. That's what we have. So evidently the other one was in an infinite loop. This one at least errors out. The other one being where we did not attach anything to DKP0 and just ran this anyway, was producing one instruction, and I think it was this one, 6467. We'll check the video to see. But notice that this has more than one instruction here. This has 6467, 6715, 6473, and we have different, I think these are polynomials, DIA, DOA, DIB, and DOAP. Here's what's really, really interesting. Notice that DZP is in here. I'm wondering if DZP, it's actually calling for DZP in the assembler language as a mnemonic. I didn't mean to call it a polynomial. I meant to call it a mnemonic. Sorry. Got too many things on the brain. That was from my CRC reverse engineering. But at least it's recognizing it as a DKP instruction. So maybe it doesn't matter that it's calling for DZP. The fact that we've successfully assigned DKP to device address octal 027 instead of its default 033, maybe that's taking care of it. We still don't know if the parameters are right, but we'll figure it out. Is the endian correct? We have no idea what seek bits means, or read zeros. Gives me a quick idea here. Let me check. Yeah, those parameters I can't find in either help file dump, help text dump, whether it's inside or outside of the running emulator. We just don't see that when we search for those parameters here. The word endian, seek bits, read zeros. We're not seeing that as a syntax here at all. I just lied. I just lied. Look at that right there. Read zeros, DBP, DKB, DLP, DSK. But that's DKP. Over here in this file, I guess we see read zeros and everything except DKP. Wonder what that means. All these other devices that don't exist, right? DEP, that device doesn't exist here. I don't see a DEP. I don't see anything that starts with D except for DKP. So the help file, text dump might have that, but I don't know what to do with it. Anyway, this is where we are, and I just wanted to document where we are in case anyone would like to take this and run with it. Maybe add some knowledgeable background information. And again, all of this is thanks to Bruce Ray. He's been very busy, but extremely helpful with what he has shared with us to provide us with the resources and the manuals and the emulator to get to this point so far. So we're very, very appreciative. Thank you, Bruce Ray, for all of your help here. And let's go on with the experimentation, shall we? Now, as I think I mentioned, I think we figured out that we have not one but two separate systems, both running 0.4 Iris, but slightly different, maybe architecture, different hardware, and maybe different builds and custom programming. But they're two distinctly different systems. Again, both running 0.4 Iris that we're getting from the tapes that we have. So I've subdivided those tapes into two separate groups. This is there's the QIC 11 format tapes and the Kennedy format tapes, and that's why I'm going to differentiate these different systems, because I really don't know how else to differentiate them other than that. That was one of the big red flags that said, hey, you probably have two different systems here if these tapes are written in completely different formats. That a tape hardware that writes one format wouldn't be capable of writing the other, and so on and so forth. And all of my research into the QIC, universal QIC reading, the hardware, it pretty much says that beyond a shadow of a doubt that if the machine is hardware set up to write one of those formats, like the Kennedy format, it cannot write the QIC 11 format. It's just, those are not the same. But anyway, also what's on them is distinctly different, so we don't have any indication that it's the same system. Just that maybe that it would have come from the same place. Maybe they were bought from the same reseller or bought from the same custom programmer, what have you. Microtech's in there, Star Technologies is in there, and both of them a little bit. That's not what this is about. We want to focus on getting this to run. The reason I brought that up is because we've actually extracted LU0 from the QIC 11 system, which is the smaller of the two systems. And I've attached, I thought, well, what happens if I attach that to DKP0 on startup and see where we get there. So let's run that. And I know what I want to do to keep this clean. While adding that, I wanted to disable the load mem of the Minicom disk tape utility, because I just wanted to load the LU0 dump. And so let's just run this here. So now we have that is attached, but nothing is loaded in memory. So we'll verify that with the show all here. And DKP unit 0 is, evidently attached to this or loaded with this particular information here. So let's boot DKP. And we get this. Now, thankfully, DKP debug is on, and we can see that we have an instruction here at 77777 NOIS, 0 DZP. Not sure exactly what that means yet, but read block 0. So I don't know if that's an error or not. But then there's a halt instruction that was encountered, but it doesn't tell me where it was. So great. Oddly enough, over the weekend, David looked at this and had indicated that he looked at this very file and did a disassembly of it, and had indicated that there were lots of halt instructions in the first block of the logical unit 0 that he thought shouldn't be there. So he thought that the logical unit 0 boot was intentionally disabled based on what he saw. So we don't exactly know what that means, but we're getting some things happening. We're doing something that we can now play with and maybe do some advanced diagnostics on, or experimentation on, to learn more about this very, very strange system that doesn't seem to be documented hardly anywhere. All right, what else can I try before we wrap this up? So I think we'll try starting with something on a tape, such as the Minicom Disk Utility. And I think CPRO did this earlier today, but I just wanted to demonstrate it. So instead of attaching a null file to mta0.trk, we thought we would attach the Minicom disk utility.bin as mta0.trk. So let's see what that does. So I'm going to go over here to the file system, and right now we can see that dkp0.raw is null. So what I'm going to do is delete the null file, and I'm going to copy the Minicom disk utility and rename that to dkp0.raw. Okay. Yes, I definitely want to change it. Alright, so now that should have the exact same content as the Minicom disk utility. And let's just verify that. We will not be attaching that. No, we're not attaching anything here. Yeah, why don't we attach a null hard drive? Why not? We'll attach a null hard drive. We haven't really played with not attaching MTA0, so we'll leave that there. Right there. And let's see here. We'll quit and start again. All right. Good. Good. Doesn't show the content of these, but let's boot MTA. Interesting. Well, I don't know why it isn't found. Well, MTA is found, right? It just says it couldn't boot from the device. Alright, well now we know that that doesn't work. Evidently what Bruce was doing by loading it directly into memory and then starting at address 377 was relevant. I would imagine he knows the same assembler stuff that David told us over the, just briefly told us in an email over the weekend, and probably looked at the Minicom utility and figured out that address 377 was the right place to start it. I don't know why yet, but as I learn how the memory loads and can see some things in this, maybe I'll figure that out. But that's also something else that we've done. So let's try this one final thing here. We're going to quit, and let's make DKP be a null file again, and we're going to turn on load mem Minicom disk utility. So go back here and manipulate the file system. What I'm going to do is I'm going to copy this null file, dzp0, because, well, we couldn't do anything with that. Because guess what? It doesn't exist. Alright, so we'll delete this version, and then we'll rename this to that. There we go. Now it's back to a null file. All right, very good. Check the parameters here. Very good. And we will start. All right. Start the Minicom disk utility at address 377. And we'll go through. We're going to work with the 40 megabyte drive. And what if we go... I'm thinking. Alright, I changed my mind. I am going to have dkp0.raw be the Minicom disk to tape utility. And this time I'm going to have it both as the tape, and I'm going to load it into memory as well. Because I want to take tape to disk and see what it does. So, let's check that out. Alrighty. That's always a good thing to do, as we know. And what else? What else? So, let's start this utility. Okay, good. Work with the 40 megabyte drive again. And let's do tape to disk. And again, no, disk to tape. The disk has something on it. The tape does not. There's the disk, 14 kilobytes. Oh, and you know what I did? I can tell just by the size. I copied the Kennedy disk utility instead of the Minicom, which is fine because I just wanted something there. All right, so let's change my mind there. And thanks to our setting up the parameters, the backspace works instead of creating a funny character. Where was that? That was, once again, this one right here. TTI DG mode equals true. We got rid of that. Okay, so we're going to go to disk to tape. Whoops. There we go. And logical unit 0, disk to tape copy. Select source, 0. Shouldn't that see... Well, no, that's the source. Logical unit 0, sure. That's what we've attached something to. Okay. And CR equals current position. Let's go with 0 again, since it doesn't like that. All right. Well, we're back to the disk, the block error 0. Not sure why, but we have that. And so we've seen this before. Something else occurs to me, that at any point I can now hit Control Break, and now it might tell me where I am, at least in this. So maybe this is a memory address, like this is, not there, but here. Maybe that's this kind of thing. I wonder. You know what I want to do? I want to boot one of those Dart utility files. That sounds like fun. Let's do that. Okay, so the Dart utility files. I'll show you on our site what I'm speaking of. The Dart utility. Let's see here. There we go. So we successfully read this, and there are 24 files on it. And over the weekend, David did a disassembly of this. And he did a disassembly of file 1. Nope. Nope. He just did an assembly of file 1 and file 2. And maybe I should look more closely at file 1 because it might be fairly obvious to me. When I open file 1, I have it set default as my hex editor here to open it with that. We see these things. So maybe every single byte is an instruction of some kind, or byte set. Maybe that's an address, and that's the instruction. Address, instruction. I'm not exactly sure, I'm just guessing. But if that were to be the case, then maybe it's that. Huh. I don't know. There's more to this. Definitely more to this than just that. So the machine knows how to interpret these things more than I do, obviously. But let's boot this thing. Let's see what happens here. So let's make file 1 be the DKP0. .raw. No. The 9-track tape. MTA0. Right now that's a null file. So we're going to rename this to be that. Good. Huh. I guess it helps if I delete this one. It's busy! Why is it busy? Because this is running. Let's quit. Can't manipulate the files when they're being used. That makes sense. Alrighty. Yep, there it is. Beautiful. Okay. So, now that we know that, what am I going to do? I want to boot from the tape, don't I? That's what I want to do. I want to boot from the tape. So let's boot from the tape. Okay. Now I have loaded the Minicom disk utility to memory. Let me turn that off and restart. Let's turn that off because I want this to be completely clean. All right. And notice this top line will change here. And it has changed. Okay, good. So well, it didn't like it. It received a halt instruction. Great. So maybe that just loaded some stuff into memory. Can I have multiple files to... Gosh, can you do this? Let's try this. Let's try the fact that these files have spaces in them is probably a problem. So I'm going to fix this. Just going to take the spaces out. Sorry to make you watch me do this. Okay. I won't make you watch me do this. Alright, I've renamed 3 of these. This is what I wanted to do over here. MTA1, and then MTA0 becomes file 01. So let's see what that does. Who knows what that'll do? Right? Let's quit. Okay. Interesting. How come it doesn't say MTA 0? Attach MTA 0. I had it right there. Wonder why that doesn't show anything. Oh well. Well, I guess I didn't do that right. But I should be able to do these commands in here, right? Should be able to do this. Huh. Well, does this file exist? Maybe that was just a simple error. Oh! Hey, look at that! Huh. Alright, so maybe I have an error here. Yep. I just had a manual renaming problem. That's what I had. But we'll fix the manual renaming problem. There. Now the file should exist. Now, it's too bad up arrow doesn't give me the previous command. But it doesn't. Alright, now let's try this again. Okay. Good. 0, 1, and 2. Still said the halt instruction happened. So how do you get it to like run? Guess you got to load it into memory, right? All right. Well, we need to play with this more, but you get the idea. This is a start. This is at least a documentation of what we accomplished so far. So if anybody has any suggestions, let us know. Thank you very much for watching this, and thank you to CPRO and Bruce Ray and everyone who has contributed to what we've been able to do so far. And David. Hopefully we'll be able to publish David's stuff soon. Thanks again, everybody. Bye-bye.